Right team, another day of fractions. I promise you, the more we do this, the more we go over things, they will get easier. And I know I spoke to some of you yesterday and you're all doing so well. You're having an amazing job and keep trying because we will get there. So today we're going to start adding and subtracting fractions. So we're going to start really simply today and then tomorrow we'll go on to the it's an extra step. It's not more difficult, there's just an extra step and actually it's things that you've already been doing. So today we are going to be adding and subtracting fractions, but they are going to have the same denominator, okay? So the important thing, I've written it here, although I realised that is a bit of a dodgy does, and I'll quickly redo that. So the denominator, when we add fractions, does not change. Remind ourselves that the denominator tells us how many equal parts the whole has been split into. So even when we add these together, the number of the equal parts that the whole has been split into doesn't change, okay? So for example, before we even start that, if you had a cake and you had 1/4 and somebody else gave you another quarter, you would have 1/4 plus 1/4, and you would simply have 2 quarters. This bottom number does not change. You add the two top numbers together, 1 plus 1 equals 2, but you still have quarters. The denominator stays exactly the same, okay? When you add them together, you're only adding the numerators, okay? So today, we're going to be concentrating on adding our numerators together, and that is it, okay? So it's quite straightforward today, so hopefully that will start to rebuild some of your confidence in fractions that we had an amazing start with. So your first questions are going to be like this, and it will say draw a bar model to help you. You don't have to, but if it helps you to see why the denominator doesn't change, then please do. So first question, we have 7 quarters plus 2 quarters. So I've drawn bar models to help us. So here are our wholes split into 4 pieces, okay? So that tells us the denominator is 4. And we're starting with 7. So we have 1, 2, 3, 4, 5, 6, 7. And we're going to add 2 more quarters to it. So we have 8, 9. So altogether we have 9 quarters. Now you might next to it have another box that looks a bit like that. And I think about you think, what is that extra box for? Let's think of how else we could write 9 quarters. And think back to our mixed numbers as well. So some of your answers will ask you to put it in both ways, both as an improper fraction, as 9 quarters, but also as a mixed number. So you have 1 whole, 2 wholes, plus 1 quarter. So 9 quarters is the same as 2 and 1 quarter. Okay, so that's exactly what you did, and you did amazingly well with the first couple of days we did fractions last week. The work that you did between improper fractions and mixed numbers was amazing. So we can draw these bar models to help us, just to remind ourselves and build that confidence back up, because I know you can do it. And then you are just adding the top 2 numbers together. So you're basically doing 7 plus 2, and that is it. Okay, so we'll do another one. Same sort of thing. So it's easy if I stand up. So we have 7, 6 and 8, 6. And we're going to draw bar models again. This time they're split in 6. So we make sure our lines match up. That one there, that one there, that one there. And we'll do one more. Okay, so we're starting with 7. So we have 1, 2, 3, 4, 5, 6, 7. And we need to add 8 more. So we think we have 8, 9, 10, 11, 12. That's 1, 2, 3, 4, 5. We need 3 more. 13, 14, 15 altogether. So we can check. We know that 8 plus 7 is 15. And we have 15 here. Our whole is still split into 6 parts, so our denominator is not changing. And we can also write our improper fraction as a mixed number. So we have 1 whole, 2 wholes, and 3 6. Okay. And for those of you that are thinking, yes, 3 6 is the same as a half. So you could also write 2 1/2. But you'll do that more of that next year. So basically, adding fractions, subtracting fractions, it is just adding the top number. As long as the denominator is the same, all we do is add or subtract the top numbers. And I know you can all do that. And I know you can all do that. So you'll be fabulous today. So the other sort of questions you're going to get . You might have to use the inverse. And I know, again, you can do that. So we know the inverse of addition, of adding, is subtraction. And one of the questions you have is something like that. So you have to work out what this missing number here is. So you have 3 6 plus something 6 equals 13 6. So using the inverse, you can switch it around. And remember, we don't touch our denominator. That is staying exactly the same. And then we're just doing 13 take away 3, which gives us 10. And we put our 10 in here. So 3 6 plus 10 6 equals 13 6. And that is it. And I think you can all do that. I'm really hoping that you can. If there are any problems, we are on Zoom again this afternoon anyway, and I'll check in with you then. So last one I want to go through is another missing number 1, but this time it's got 2 missing numbers. So we have 11/8 plus something over 8 equals 21/8, which equals 2 and something over 8. So we've got 2 boxes to fill in this time, but again, you're doing the same thing. So we have 21/8. We're going to use the inverse again because we want to work out what this number is in the middle. So we're going to use our answer to take away what we know so far. So we're going to take away 11/8. So our 8 stays the same. Our whole, whatever they are still split into 8 equal parts. And we are just taking away 21 from 11, which gives us 10. So now all we've got to do is convert our improper fraction to our mixed number. So the other way of doing that is, I'll use this pen. We know we have 2 wholes which are made up of 8 equal pieces each. So we have 8 plus 8, which is 16. So our 2 whole equals 16 over 8. There are 2 whole pizzas of 8 pieces each. So we have 16. So if we know that this whole 2 is making 16 over 8, we need to get to 21. 17, 18, 19, 20, 21. So we need 5. So you could then do 21 over 8, take away 16 over 8. Because you know you need to get to 21 over 8. And we know that this 2 already is 16 over 8 because it is 2 whole 8s. So we know that 21 over 8, take away 16 over 8, gives you 5 over 8 to fill in this gap. So I'm going to very quickly go back to the beginning and remind us why we don't change the denominator. And today you're going to be focusing on the numerator, adding and subtracting using the numerator only. So I hope that it will be relatively straightforward. So, as a reminder, we don't change the denominator when we are adding and subtracting fractions that have the same denominator. If we have an 1/8, so we have 1/8. And we are given 2/8. We still have the size of our pieces, they are still 8s overall, but now we just have 1, 2, 3. The size has not changed, it's just the amount of them that we have that has. So it's just the numerator that is going to change. I hope that's all right for today. Give it a go, and if you need any more help, let me know on Zoom this afternoon and I'll pick up any misconceptions and you can stay on and we can work through some things. So I will see you later on. Bye.